Let's move on to geotechnical engineering, and you'll already see how different these disciplines are. Geotechnical engineers are concerned with the behavior of earth materials like rock and soil, but the main focus is soil. This may seem odd, but you'll see how important this is. The structural engineer can do everything right to make sure the building will stand up, but if the geotechnical engineer messes up and you put a structure on soil that can't withstand it or is uneven, the building could fall, sink into the ground, or even lean to one side, probably the most famous being the Leaning Tower of Pisa, which was a result of soil issues. Then they also have to consider the foundation of the structures that are being designed, like should they have a shallow foundation or a deep foundation. You may not realize it, but our houses and all the buildings you see have foundations that go underneath the earth to keep the structure as stable as possible by transferring the weight from the structure to the earth. But geotechnical engineers rely heavily on testing. So a lab you might see in college is to go out as a class and collect soil samples around your university and bring them to lab. You would have to classify it, like is it sand, gravel, clay, etc. There are many soil types, and you may have to look at the grain size or how it reacts to water. You determine its water content by analyzing the sample, which will be comprised of a solid soil, water, and air of different masses and volumes. But most importantly, you'll measure how the soil will react to mechanical loading or to different forces acting on it. So you might perform a triaxial test, for example. Too complicated to explain for this video, but essentially you put the soil in an enclosed area and apply a force or load to the top which pushes down on the soil. Then pressure sensors measure the pressure at different points to see how the soil is being affected. If you imagine a square sample of soil and you add a force to the top, the soil can fail along some weak plane. Basically, the weight overpowers the friction holding the soil particles together, and the soil will start to slide, which is known as shear failure. Its ability to stand up to this is known as shear strength, which is one thing that the triaxial test on the left tests for. And this leads us to what a career in geotechnical engineering could be like. You might be the person who goes out to the field where a structure is going to be built and collects soil samples all around the area for testing. Or you could do testing at the field. One of the most used tests right now in this field is cone penetration testing, where a large truck goes out to the field which has all this equipment on it, and a cone is pushed into the soil, and the pressure will be monitored by a computer on the truck as it moves through the soil into the earth. Based on the pressure, you can analyze the soil mechanical properties. Or maybe you could work in a lab where you would do the testing on the soil after it's been collected, like I showed with the triaxial test. Or maybe you could work on the computer and input the different types of soil from the various locations at the site, so you can digitally lay out the area that the structure will rest on. So you could be in the field, in the lab, or on the computer. Your elective classes could include geotechnical earthquake engineering, which would be like learning the dynamic behavior of soil as opposed to the structure itself. Then slope stability analysis and how to safely design structures on slopes. An example would be an embankment dam. Analysis of deep foundations, where the structure goes deep into the earth for a stronger support, like for skyscrapers. And of course, there are many more classes.